All right, let's dive right into it. How exactly did Netflix know their servers were failing before a single customer even complained?
Or think about this. How did they know a database node was locking up before a single person's movie even started buffering?
Well, it's because they didn't just sit around waiting for humans to notice the problem. No, they built a system that actively monitors its own heartbeat, right? It detects the exact moment an organ starts completely failing, and it literally performs surgery on itself while the engineers are fast asleep. So let's look at exactly how AWS detects these outages before humans ever do, and how you can engineer this kind of self-healing automation for the DVA-C02 exam. To understand how AWS actually knows your server is dying, you really have to understand Amazon CloudWatch. You can think of CloudWatch as the central nervous system of your entire AWS architecture. It's this monitoring and observability service that continuously collects and tracks data across all your applications. And the most fundamental building block here, it's called a metric. A metric is quite simply a time-ordered set of data points. Think of it almost like taking a server's pulse. Every few minutes, your Amazon EC2 instances are automatically sending metrics back to CloudWatch, things like CPU utilization, disk reads, and network traffic going out. But if you've got 1,000 servers running, how do you find the exact pulse of just one? Well, CloudWatch organizes this massive ocean of data using what we call namespaces and dimensions. A namespace is basically your top-level container, something like AWS/EC2 or AWS/DynamoDB. Then you have a dimension, which is a specific name-value pair that uniquely identifies the exact resource inside that container. For example, instance ID equals I-123456789, and this is exactly how you filter out all the noise. You're telling CloudWatch exactly which server it needs to look at. Now, here's where this gets really interesting. A metric by itself is completely useless. I mean, it is just a number sitting on a customizable CloudWatch dashboard. If a server's CPU spikes to 100%, sure, the dashboard is going to show a big red line. But if nobody is actually looking at the screen, your app still crashes. So to actually protect your production environment, you absolutely must build CloudWatch Alarms. An alarm actively watches a single metric over a specified time period. You go in and set a strict threshold. For example, you might tell the alarm to trigger if the CPU utilization goes over 80%. But listen, this is where people mess up, and it is a massive trap on the exam. Imagine a developer sets the alarm, a server experiences a tiny 1-second CPU spike, the alarm instantly triggers, and it completely tears down a perfectly healthy server. Why did that happen? Because they didn't understand operational behavior. CloudWatch alarms do not invoke actions simply because they hit a state for a split second. No, alarms invoke actions for sustained state changes only. You have to configure the alarm to evaluate the metric over a specific number of periods, like exceeding 80% for 3 consecutive 5-minute periods. You only want the alarm to take action when the server is actually dying, right? Not when it just sneezed. So when the alarm finally does trip, it initiates some automated actions. First, it fires off a message to an Amazon SNS topic. SNS instantly pushes a text message or an email directly to your on-call engineer's phone. Second, the alarm triggers an Amazon EC2 autoscaling policy. Autoscaling immediately steps in, permanently terminates that dying, unresponsive server, and spins up a brand new, perfectly healthy instance to replace it. I want you to think about that for a second. You didn't write a single line of recovery code. You didn't manually log into a server to reboot a service. You literally just mathematically defined what healthy looks like, and the AWS ecosystem automatically healed your architecture the very second it drifted from that baseline. Now, imagine this scenario. You deploy a highly complex application. Out of nowhere, users start complaining that their shopping carts are failing to check out. You panic. You check CloudWatch, but the EC2 CPU is fine. The network is fine. The database is perfectly fine. All your standard AWS metrics are telling you that your system is running perfectly. But your system is actually burning to the ground. Why does this happen? Well, because standard AWS metrics only monitor the underlying hardware. AWS has absolutely no idea how your specific business logic is actually performing. It doesn't know how many failed logins you have or how many shopping carts are crashing. So to fix this, as an AWS developer, you have to build custom metrics. You write code inside your application using the AWS SDK to make a PutMetricData API call directly to CloudWatch. That way, every single time a checkout fails, your code publishes a custom data point straight to CloudWatch. But there is a catch here. If you're running, say, a massive flash sale and thousands of transactions are happening every single second, the default 1 minute or 5 minute metric resolution is just entirely too slow. I mean, by the time 5 minutes passes, you've lost thousands of dollars. So, for critical, real time production monitoring, you absolutely must configure high resolution metrics. This feature allows you to publish and track custom metrics down to a 1 second granularity, meaning if that shopping cart fails, you know about it in exactly 1 second. You do need to watch out for the data retention limits, though. Your standard 1 minute metrics are stored for 15 days, but those incredibly dense 1 second high resolution metrics, CloudWatch only retains those for exactly 3 hours before they expire. If you don't act fast, that granular data is gone forever. And just as a quick side note to remember, you cannot manually delete a metric in CloudWatch. You just have to wait up to 15 months for it to automatically expire on its own. All right, let's lock this down. 3 rapid takeaways for you. Number 1, CloudWatch organizes monitoring data using namespaces and dimensions, which allows you to isolate and track the exact performance metrics of individual AWS resources. Number 2, CloudWatch Alarms evaluates sustained state changes over time to automatically trigger Amazon SNS alerts and auto-scaling policies to self-heal your infrastructure. And number 3, you must use the PutMetricData API to publish custom metrics to monitor unique application logic, and use high-resolution metrics for 1 second visibility during those critical events. I'll leave you with one final warning. Never, ever build an alarm that only sends an email. If your only response to a dying server is to wake up a human and ask them to fix it, well, you have fundamentally failed at cloud architecture. Automate the recovery. So I have to ask, is your cloud architecture currently working for you, or are you working for it?